Okay, so last time we were defining the load combination before, after running the analysis. So I'm gonna use the load combination 1.2 dead, 1.6 live, and then I'll hit OK. Then let's just show the deformed shape due to the load combination. So for example, I'm gonna display deformed shape, and I'm gonna click on load combination, and I'm gonna show contour lines. Okay, so I'll apply. All right, so this is how, if you guys remember, last time I was like talking about the deflection at the maximum deflection on this slab. And it's around here. So if I put my cruiser on this point, it has 2 millimeter deflection. Okay. So that's what we stopped at last time. But let's see if you guys remember, when we talk about the bending moment for a slab, it's not like beam, it's a 2D element. Slab beams is like a 1D member. It just like have a bending moment in one direction. It doesn't have like a second direction, but two-way slabs, talk about two-way slabs. So do you guys know what is the difference between one-way slab and two-way slab? What is the difference? The load distribution, which alter the values of the moment. So if you have a very long, like a corridor, like this corridor, the slab on this corridor, it's supported by a beam here and a beam here. And there's a very, very long slab. This slab acts like a one-way, only bending this way. It's not easy to bend this way because it's a very, very long. It's supported from here and here, so it only have one-way bending moment. So usually the main reinforcement for the one-way slab is in this direction, okay? But right now we have like 5 by 5. So this is usually a two-way slab. So basically think about it like if you have your slab is rectangle 5 by 5, so usually the load distribution is something like this. You take like a 45 degrees here and a 45 degrees here. So it's going to be something like this. So the load goes here to this beam, and the load goes to this beam and this beam. So basically it acts in two-way. But if you have a very like a corridor, look, if you make a 45 degree, something like this. So basically most of the load is going in this direction. However, this is very, very small amount of load that you can neglect it. So we consider that this slab is a one-way slab and all the load is going on the other direction. But in our case, it's a two-way slab. So usually it has bending moment. It bended this way and it bended this way. So when we design, we put reinforcement in the two direction. And how we show this in SAP2000? SAP2000 have a feature that you can show bending moment M11, which is the bending moment in X direction, and M22. And this are the most important internal forces in the slabs that we can get from SAP2000 when we design slab system. So this is one thing that you need to take care about. So let's see, how does the bending moment look like? If I want to show it, I will go to display forces, and then I will hit shells. And this is the most two important internal forces, M11 and M22. Let's see how's M11 look like. And I will say, okay, let me make this XY view. And let me close this screen to make it much bigger. You guys know what is the direction of this moment? Like, is this the moment that shows the beam is bending this way or this way? Like if I'm taking a strip, M11 is this way, is X direction. So if I take a second here, it will show you the bending moment of the beam is something like this. And this is the actual bending moment. But if you take a strip here, it will show you a random moment. Okay, so this is what we are looking at. So if I want to calculate how much reinforcement that this beam is need for this direction, I need to show M11. If I want to calculate the reinforcement in the Y direction, like the reinforcement that I'm gonna put it this way, I need to show M22, not M11. So let's focus on M11. So if I'm showing M11, so I want to see what is the bending moment in this slab. So what I'm gonna do is I'm gonna take a section here and see how the bending moment look like. So to take a section, let me go to display. Let me remember. Draw. Yeah, section cut. So I go to draw and I go to section cut. So let's have a section cut here. Draw. So you will have to click on the point and you keep your left click still intact. So you don't leave your finger from the mouse. And then you will go to the other point, something like this, and then you leave the click. So it shows you how does the bending moment look like, and that's what we are used to, right? We have a parabolic, something like this, and there's a column, so there's a negative moment, and then there's a positive moment, negative moment. So this is how the bending moment on a slabs look like. In a span, in between a span, it's positive. Over the column is because it's over the support. It's think about it, it's like a beam. Like for this bay, you have a column here, 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 here. So this is how the bending moment look like. It's in a span positive, and then over the column is negative, and then it's positive, negative, positive, something like this. Okay. All right. So what I did, I take a section around mid-span, like here. Let's see how this is gonna look like when I take this section over the column here. Can you see what happened here? The bending moments look reasonable, like at these sections. The bending moment, let's look at this color, the green. It's about 2 ton meter, 2.1 ton meter. But let's see what will happen over the column. How's the bending moment look like? Let's take another section cut. So draw, section cut, and let me draw this section cut here over this column. Look what happened at this column. All right, so everything is good. Like here, 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 until I came at this point. What happened at this point? There's a huge shift in the bending moment. Like it makes a very, very bad triangle at this moment. So this is not right. This happens because of the modeling issue that we model the columns as a point, as a needle. However, in real life, it's a column. So what we use if we want to get actual bending moment, so what we do is that if we have the cross section of the column 50 centimeter by 50 centimeter, so we come here, I know that this is 50 and this is 50. So you take the bending moment at a point like the 50 centimeter and d/2 from the face of the column. So it's something around here. Why it's a d/2? Okay, let's assume that we have our slab in real life, something like this, right? And the column is 50, something like this. So this is the slab thickness, and this is the column. What we did is we modeled the slab as long. Can you guys see? Or we need to turn on the lights. Can you turn on the lights back here just 1 minute? Yeah. So what we did with modeling the slab is that we made a line in the middle, not the whole thickness. And we made a line in the middle of the column, something like this, right? But the actual one is something like this. So what we do is like we go 45 degrees, something like this. And if you went 45 degrees, this is about d/2 from the thickness of the slab. So this is where you should take the bending moment for the slab. So if you take this amount of bending moment, like it will be really huge. Like you will need a huge amount of reinforcement, which is not right because the column has a section. If you think about it, okay, but this is what the SAP2000 gave me. I should design for this amount of moment. Okay, if you want to design this amount of moment, you will find that the slab thickness that you needed to face this bending moment is infinity. Because you need a huge amount of thickness of slab. Reinforcement is not enough. However, the actual slab thickness at this point is infinity. Because of the column, right? Because what is the slab thickness here is 0.2 centimeter, 0.2. Until you come here, where's the column at? The slab thickness is the length of the entire column, which is the length of the entire building. So the building or the slab is gonna face the bending moment here if this moment is there. Because here there's a huge thickness, which is the thickness of the column, the length of the column. So it doesn't make sense that you calculate bending moment where the column is at. Okay, so we go like here and here in the middle. So if we go there, we will find that the bending moment values are reasonable. So can you turn off the light? Okay, so let's see what is the value of the bending moment here. I'm gonna zoom in. Okay, so the bending moment here is -2, which is reasonable, but look what happened if I go inside. -4, -6, -7, very huge, like 3 times the actual bending moment. So if you decided to put like an area of steel X, so you will end up with 3X just to face this amount of bending moment. All right, so I just want to make this point clear. Let's just display bending moment on shells in M2 in the other direction. So it will be the same like the other one, but it's in the other direction, in Y direction. So if you take a section, it should be this way. And from this section, we basically do the reinforcement on the other direction. Okay. All right, so I'm not gonna go deep inside the design, how we calculate reinforcement, because this is not the topic of the class, but all what we want to do is that you get actual internal forces. Like, don't mislead it with the value of the bending moment over the column, because this is not the value that you are gonna design your slab on. So we pick the right values. But when it comes to design, if you are interested, I believe I have other YouTube recording on how to design slabs. But we are focusing in this class on the analysis and the internal forces value. Okay, so let me tell you something. And when we do, like, if you are in a firm and you are doing design for buildings, we usually design as a 2D slab at the first. So when we design for gravity loads, if we want to get the reinforcement in this slab, or we want to get initial reaction in the columns. So what we do a 2D model. Like, this model is enough to design your slab. You don't have to have a 3D model for the entire building. This 2D model is enough to design the slab system, the beam system, because this we call it's a local system. It's local on the floor. It doesn't impact much the entire building performance. So we can if I'm not depending on the beams to resist seismic, so I can design the beam right now to only take the gravity load, the bed, the light, the flooring, and everything. And I can't design this system. However, if I'm going to do seismic analysis, this model is not enough. Seismic analysis need a model for the entire building. Okay. And to do a model for the entire building, you need to initiate some parameters for your, like, you need a value, like what is the column size? So how can I get that? So what we do is, if we have this building is a 10 stories, I take one story and do 2D analysis, get the beam sizes, get the slab sizes, like based on the bending moment, I decide on the reinforcement and decide on the slab thickness. And I get reactions. What is the reaction at these columns? And I multiply it by 10 so that I can know how many tons that this column is gonna have. Like, so I design, like, for example, 50-ton load on this column. So I know that the dimensions of everything. And once I know everything, I can go to the 3D model and do seismic analysis. So first, we do gravity analysis, like 2D model, get the beam done, get the beams, the slabs, and also initial sizes for the columns. Why I'm saying initial sizes for the columns? Because right now I'm designing the columns only to take the gravity load, like vertical load. Once I'm getting this initial size, I push the building with the seismic or the wind load, so I get what is the bending moment that this column has. And then I redesign the column to under axial load and bending moment from the earthquake. If you started with earthquake design, you will stuck with what is the dimensions of the columns that I should start with. So you need to do gravity analysis, 2D model, get the reactions at the columns, get the reactions on the columns, design them, get dimensions, and once I get the dimensions, I can do seismic analysis with the initial dimensions that I have. So let's assume that we are done with the analysis of the 2D. We got the bending moment on the slabs. Also, you can show the bending moment on the beams, and I get reactions on the column. Let's see how can I convert this model into 3D model. Let's see how can we do that. Okay, so I'm gonna save as this model as a slab 1 3D. All right. So what I'm gonna do first, we are gonna have a little bit of a change since we are gonna do this for seismic. I'm gonna add 2 walls to this system. So I'm gonna do a little bit of modification. I'm gonna remove the column here and column here and make a shear wall here. I'm gonna remove the column here and column here and make a shear wall. So let's see, how can I do that? All right. So I'm gonna just, where's the area? I'm gonna not remove, just like make the slab invisible so I can handle. So what I did right now, I didn't remove the slab. I just made it invisible. You go to this set display option, this box that has a check mark, and I said that I don't want to see the areas, not in the view. Okay. And what I'm gonna do right now, I'm gonna delete. All right, so I have. Right. This frame element, I'm gonna delete it. And I'm gonna delete this one as well, because I'm gonna do a little bit of a change to these elements. And I'm gonna make restore the full view, and I'm gonna redraw them. So I'm gonna redraw the beam 25 by 70 to make it from here to here. And I'm gonna do this one to draw it from here to here. And okay, I'm gonna draw another frame element, but let me see if there's another name. Yeah, I'm gonna name it none. None means like it's a dummy element, doesn't have a stiffness, doesn't have anything. So it exists, but doesn't contribute to the stiffness of the structure. Okay, I'm gonna name it none, and I'm gonna draw this at the location of the walls. Here and here. By the way, right now I'm trying to draw a 3D model for the structures that we just saw right now. But let's assume that this is the structure that we started with. Like, do you guys remember what is the difference between this one and the one that we drew? The one that we did is have a column here and column here, not a shear wall. Same thing here. But if I want to model this in my model, all what you have to do, you will select all the joints here and make it hinge. Because this is what the shear wall is doing here. It restrains all the vertical reaction at this point. So all these points doesn't move. So I make it hinge. And same thing, I select all the joints here and make it hinge. But what I'm gonna do it right now, I'm gonna create the model in the 3D. So I need to model the actual wall. So let's see how we can do it. Right now, I draw the wall as a frame element. And what I'm gonna do right now, I'm gonna select this frame element that I just drew. You can either select it manually, or you can go to select, and you will select the properties, frame sections, and you will click on none. So it will select all the frame section that it named none in your model. And this is very helpful if you have 20 or 50 sections that are named none. So you don't have to select each one by one. So you select them one at a time. So I select them. So what I'm gonna do right now, I'm gonna tell SAP2000, extrude this line and make it as a shell element. Okay, so make this line and extrude it as a shell element. But we didn't define the wall section right now. So let's go define this section before we extrude it or make it as a shell element. So how can I define wall? You will go to draw, define frame section area, the same way that we defined the slab last time, if you guys remember. And I'm gonna add copy, or you can add a new section, and we name it maybe wall 30 centimeter. And this wall is concrete, and it's a shell thin because the thickness is small with respect to the other two dimensions. It's not raft foundation or something. And I'm gonna make the thickness 0.3. And I make sure that the material is concrete, and I'm done. And I will hit OK. Okay, right now I defined the wall section. The next step is to see how we can convert this beam to a wall. So you will go to Edit, and in Edit, you will find an option is called Extrude. And you will find option is called Extrude Lines to Area. I click on this one, and it asks you, when I do this extrusion, do you want me to assign a section name slab 22 centimeter to this area or something else? I will hit something else. I need it to be wall 30 centimeter. And I ask you a few questions. How do you want me to do this extrusion? Do you want me to do this extrusion in x-axis and y-axis and z-axis? What do you guys think? I have the frame section in this, like this. I do the extrusion in which axis? C, right? And saying that the story height is 3 meters. So what is the value of the extrusion? Is it positive 3 or negative 3? Negative, because I want it down, right? Because the wall is supporting this system down, right? Okay, so it will be -3. So I put -3 in VZ, and the number is 1 because I only have one story. And it gives you a very interesting option. It asks you, do you want to delete the section or you keep it? Delete the source object or keep it? This is a non-section, so it doesn't have any property. If you want to keep it, you can keep it. But if you want to remove it, it will be the same thing. I would remove it so that I don't mess with my model. I don't want to have many sections on top of each other, okay? So what I'm gonna change here, I'm gonna make this 0, and I make this -3, and the number is 1, and delete the source object, and I will say okay. Oh, where's the section? You need to have another view, the 3D view, to see where this wall is drawn. So if you want to make another view, you click on this arrow and add new window, and you will find it here. Can you see? It's over there. So if you want to show, I'm gonna make this to show by section. Okay, so let me make it in view. It's something like this. So I made the walls. So the next thing is I want to make the columns from points to extrude it to be line, right? Because I want to model the actual height of the column. So what I have to do right now, I want to select all the points that has hinges, select all of them, and then extrude point to line, not like the walls. The wall I extruded line to area. So how can I select all the hinges in my model? So I will select, you can select them one by one. Like what you can do, you can select this, and I believe this one, and this one. I didn't select these two and these two because there is a shear wall here, but I will select the corners because there's columns there. So this is one way to do it, one by one. Or you can select, and you will go to assignment, join supports, and you click select, and it will select all the supports that you already defined from the last model. But right now I select them by myself. So what I'm gonna do edit, extrude. And once you click on extrude, you will find an interesting thing, that everything is deactivated except one thing, extrude points to frames. Why? Because I only selected points. But if you selected points and lines, you will find this one is also activated. Okay, so let me go with edit, extrude, points to frames. And okay, I didn't define column. Let's define column section first. Define section, frame section. I'm gonna add a copy of this one. I'm gonna say it C1 50 by 50 centimeter. And I'm gonna change this 0.5 and this 1.5. I make sure that the material is concrete. I hit OK. Okay. So I go back and I edit extrude. Right now I define the frame section of the column. And I will ask SAP2000 to assign section C1 50/50. But if you want, you can assign the beam section. And once you are done, you can select all the columns and assign a new section. So for example, let's say that you messed it up and you clicked on beam 25 by 70 and you make it -3 down 1 and you hit OK. You'll find that all the columns are here. All right. But if you click on one of these columns and you want to know what is the section of this column, you right click, you will find all of them have the beam section, not the column section. So if you want to change them, you can click on all these columns and you go to assign frame section, and you put column C1 50/50. So right now, all of them has the new section. So everything can be fixed at some point. Okay. All right. So right now I converted my 2D model to 3D model. You guys tell me what is missing. Can I run my model right now? Or there's something missing? There is few things missing. But what is the most important right now? What will happen if I run my model as is right now?
Need some actions at the bottom.
So what is missing? I don't have supports, right? I removed all the supports from here. Okay, let's see. Did we remove the supports? I think because if I okay, let's run it and see what will happen if we run it this way. Definitely, if there's no supports. Okay, you tell me what happened. Actually, it has reactions like the same model. So why this happened? So right now, if the model doesn't have support, so it will have a displacement of like millions of centimeters. Okay, so we'll find these values. Like if we show, let's show the deformation display, deformed shape, and let's say okay. All right, so what happened here right now? Can you guys explain? I should put supports on the column. No, but why this is it stable? This one looks not stable, or this one, it's a stable, by the way. I'm saying it has like a weird deformation. But what happens here is that we didn't remove the supports that we already defined for this slab. We have it from our previous model. So in my model, this shear walls and these columns is supported by the slab on the support up there. So I didn't remove the supports that I have from up there, and I didn't bring them down. So what I have to do, I have to remove the joints, the hinges that I put here, and put hinges at the columns, right? Because the columns is the one who supports the slab. So I need to remove all the supports that I redefined in my previous model. So let me unlock the model. And what I'm gonna do, I'm gonna click on all these joints on this floor, and I say assign joint restrain and remove all the restraints from this floor. So it will remove the hinges from the 9 points or the 12 points that I have here. Okay, because I need to remove the hinges. So I need you to distinguish between what we did a few minutes ago. What we did 2D models. The slab system is supported by hinges in 2D. And we decided a few minutes ago that we need to move this model from 2D to 3D. So we are going to remove all these hinges and make columns, and this columns is going to be the support. Okay, so I remove the hinges from up there, and I'm gonna go to the floor down and put hinges or put fixation or whatever that I want. Okay, so to go to the next floor, I'm gonna do a little bit of a trick here. I'm gonna edit the grid and add and modify the grid system, and I'm gonna make a Z grid at -3. Making a grid at -3 will make me to use these two arrows to move between the Z grid level. So I will go down. So down, I'm right here. Yeah, so here it shows you are in XY plane, Z equal -3. If you go up, it will tell you that you are at Z equals 0. So I will go down, and when I select all these, it selected some joints. What are these joints? Is the end joints of the columns. And I'm gonna put a support at the end joint. So let's assign joint, restrain, and I put hinge, and I will hit OK. So there is hinges at these supports down here. So if I view the 3D, can you see the hinges? All right. If you want to show the slab, I can go here and make it in the view, something like this. All right. So let's run the model and see what we are gonna get. Actually, the model is good right now, but it has some mistakes. We are gonna fix them. I'm gonna tell you in a few minutes. Run now and see how it's gonna be different. Yeah. So let's see what happened now. The columns has different, can you see? The columns is supported here, and the columns take the load from the slab or the beam system. So the slab give the loads to the beams, and the beams give the load to the columns, and the columns is supported by hinges, which are the foundations. And the slab is running good, but there is something I hope that you guys notice. What is it? The shear walls. What was happening here? They are not connected. Why? Because we talked about things a few minutes ago, right? Because SAP2000 or any finite element software, it's connected or do solutions at the joints. Okay, so I have many joints here, but this element only has 2 joints, so they are not connected. This element only feel the slab here and here. So if I want to make this wall feel the entire slab, I need to divide the slab with joints that matching this joint, so they get connected together. Okay, so let's see how we can do that. So I'm gonna unlock the model and select the wall. How I can select the wall? I selected by selection, assignment, properties, area section, and I will select wall 30 centimeters. So it will select the 2 walls. So I select the walls, and I'm gonna show this in XY, and I will go to level 0. I'm gonna select the joints that intersect with the wall. So I'm gonna select these joints. There's many ways to do it, but I'm gonna do it this way. I'm gonna select these joints and these joints. These are the joints that intersect with the wall. And let's view 3D. And I'm going to edit area, divide area. And I'm gonna divide this area with these joints. So there is an option here. It's divide area using cut based on selected point objects. Okay, so I cut this area at the selected points, and then I will say okay. So we'll find that I was able to cut the wall at the selected joints. So I'm sure right now that these joints is connected to the slab. If I run the model, it's gonna be run, and it's gonna give me good results. But I'm gonna do a next cut. What is this next cut? We usually need to make the aspect ratio of the elements around 1. It's not preferred to have the aspect area of the mesh Like it can be 1.5, but the aspect ratio of this element is more than 1 because you have 0.5 and 3 meter, like the aspect ratio is 6. So I'm gonna make another division to the wall section. So I'm gonna select the wall section one more time. Select, properties, wall, area section, walls 30 centimeter. Select all of them. And I'm gonna go to edit area, divide area, and I'm gonna make another division. This division is gonna divide the wall section into 6 elements in this direction, in 1, 2 direction, this direction. So why 6 elements? Because I know this is 3 meters. And if I want to make it 0.5, so I have to divide the 30 meter into 6 segments. So let's see what will happen if we hit OK. All right, can you see what happened here? It's almost mesh 0.5 by 0.5. Okay, so right now I divided the mesh and I made sure that all these points are connected. What else is missing? Should I run the model right now or I missed something? Yeah, so I need to go back to the base and make all these hinges here and all these hinges, all the joints here, like all these joints should be fixed or should be hinged because there is a foundation and the strict foundation under this wall or the pile cap or whatever is fixing or hinging all these sections, not at the start and the end. So I select all these joints and I'm gonna assign joint, restrain, hinge, okay. All right, so let's make this as a full view and let's run the model one more time. So right now it makes sense. So if I want to see the deformity shape, this is how the deformity shape look like. The shear wall is getting deformed with the slab very well. They are well connected. There's no separation and everything's working. Right now, this slab is good to go. All right. So this is a 3D model of the slab. So if you have a 10-story building, so I need to replicate this story in the all 9 stories. So once you model the first story, it's done. Like it's just one step to make the 10 stories. Unless if there is a huge variation in the stories, like let's see that the first 3 floors have something similar, and after another 3 floors, there is a huge change in something, in a structure system, in the slab system, a huge like reduction in the loads, huge reduction in the. So you need to make something. So this one thing that we are gonna do right now. I'm gonna unlock my model, and I want to select the system without the support. Like I want to select this structure without the hinges. Why? Because if I select the hinge and replicate the hinge in each story with me, so that means each story is supported by hinges. However, in real life, this entire structure is supported by the foundation, which is at level 0. Okay, so how can I select the structure without selecting the boundary conditions? So you can go to view, set 3D view, and you make it XZ. And I'm gonna say, okay, so this is with angle. If you want to view this 3D view and you make this angle is 0, the aperture angle. So right now I'm seeing the structure in 3D view, but in XZ. So it's like you are looking at your structure from here, but you see everything behind. If you hit XZ from here, it's a 2D view. You only see the face of the front, like this way. Like if I select these columns, it's gonna select only these columns. But from this view, if I select everything here, it's gonna select this face and everything behind, because this is a 3D view. So let's see what will happen. I'm gonna select this and I make sure that I'm not selecting the support. So I didn't make it from here, a little bit above 0. So let's see how's the 3D look like. So I selected everything. Can you see? But if you made XZ view and you did the same thing, don't know what happened to this one. Let me add another view. Okay. Let me escape and I will do the selection one more time. I'm gonna make this XZ and I'm gonna select these. Sorry. Let's view the 3D. Can you see what happened? When I did the selection from XZ, it only selected this first. Why? Because this is a 2D view, not a 3D view. But what I want to do, I want to make this as an XZ 3D view. So when I select something, select this and everything on the back. So to do this, you go to view, set 3D view, and you make this angle, you make this XZ, and I make this angle 0. And what I'm gonna do, I'm gonna select it like this. So I'm gonna select the entire structure. And if I want to make 10 stories, this is story number 1. I go to edit and I find option is called replicate. And it asks you a few questions. How would you like to replicate this structure? I want to replicate it in which direction? Z, right? So I make X and Y equals 0 and Y is equal 3. It's positive. And the number, I'm gonna add 9 stories on top of story number 1. And it asks you, do you want to delete the original object? Do you want to delete it? No, because we want to keep the story number 1. And I'm gonna hit OK. All right. And then right now we have our 10-story structure. So let's restore the full view. And it's something like this. And the model will be a little bit heavy. So bear with the model a little bit. Let's just show objects. Yeah, so this is how the structure, if you want to show extruded view, like you want to see like the real thickness of everything, so the model will be a little bit heavier because it extrudes the whole thing. So this is how it should be the structure look like if you want to rotate it. So will be a little bit slower, but you wait a few seconds until it loads everything. And this is our structure. So right now, this 3D structure is ready for seismic analysis, because seismic analysis and wind analysis, which is the procedure that you have to do for tall buildings or even any building right now, that you need to have a 3D model of your structure. And once you have it, you push it with the seismic load or you push it with the wind load and get the bending moment on the lateral load resisting system. And in our structure right now here, the lateral load resisting system is the shear wall. There's 2 different ways that we can design this structure for lateral load. Some people will decide, okay, what I'm gonna do, I'm gonna make the shear wall to be designed for the entire earthquake. So I'm gonna neglect the contribution of columns and beams and the stiffness and the lateral stiffness of the structure, and only rely on the shear wall to take all the seismic load. So this is one thing to do it, but the shear wall section will be a little bit bigger. But some people, okay, I'm gonna take into account that the columns is gonna resist in the seismic load, so the load on the shear walls will be a little bit less. Okay, so this was a simple structure to do. I'm gonna do. Does any of you have any question so far?
Asking the deep test say the entire earthquake would be carried by the shear wall or by the shear wall plus the column. So
It depends on you, on what you decide.
So the same thing can be done for the window because it's a lateral load.
Yeah, same. So seismic and wind, you can decide what is the lateral load resisting system. I can say that this is a pure shear wall and only rely on the shear walls to be designed to take all the seismic load and neglect the impact of columns. However, what will happen in the real life, the columns is going to get contribution. But the shear wall is designed, if the columns fails, the shear walls is going to take everything and the structure is going to good to go to resist the entire loads.
So if I design the shear wall take all the lateral loads. Then
Yeah.
the column is actually providing the additional factors.
Exactly. So let me tell you something. So usually when we design like tall structures, everything is contributing and resisting lateral load. However, we neglect many things as like a factor of safety, like even the stairs. Do you know the stair system? The stair system is a very stiff system in your structure. Can you imagine you have a core in your structure and has an element that goes this way and this way? It holds the structure. So stair system contribute to the stiffness of the structure, but we neglect it in resisting lateral loads. Even if you have break walls, like we don't have break walls here. So the infilled frame system, like infilled with break walls, it contributes to the lateral load resisting system, but we also sometimes neglect it. However, some designers can consider the infilled frame with break walls in resisting the lateral loads, but it depends on the designer itself. Okay, so it depends on you. Do you want to include them or not? So if I want to include the stair system, I don't have a stair system here, but I need to draw the stairs and include everything in my model. Okay. Right, so what I'm gonna do right now, I'm gonna do an example very quick. And with you, I'm not gonna finish it, but maybe it will be a homework that you guys will finish it. But let's just start it. We have like 20 minutes. So let's see what we can finish in 20 minutes. I was trying to explain everything to make it easy for the next example, okay? So let's save as this model. Let's say save as, because we have some sections defined here. And let's say it's a slab 2. And I'm gonna delete everything that so let's Control O. Select everything and delete it. I can do this. It'll take some time. All right, until I finish, I'm gonna do this example very quick. This is a big structure. This structure is a multi-span building. It has 8 shear walls. The span is 7 meter, 5, 5, 5, 7. So the big span is 7, the small span is 5. Has column distributed each 5 meter. Have a core system that has the elevators in this area. This shear wall is connected by a beam. It's called a coupling beam. It coupled the shear wall together. And it has a beam on the perimeter. And it will be 25 by 70 centimeter, like the same example that we have done. Columns are 50 by 50. The shear walls is 50 centimeter thickness, like the same shear wall. And the length is 3 meters. This is 3 meter, 3 meter, and 3 meter. And this length is 5 meters. So let's see how we can do it. So I'll get back to SAP 2000. And what I'm gonna do, I need to change this grids, right? Because it's different from the grid system that we have. It's very easy to do that. So we will go to edit grid data, modify, and from the grid system that I show, I have X0. You guys tell me, what is the grid spacing that I need to build this model? 0. What is the next? Here, right? At the shear wall. So I can draw this shear wall at 3. And then here, this is at 7. And then after 7, 12. And a 1 here in the middle. And this is 5. So 2.5 plus 12 is 14.5. And sorry, 7. Where 7 plus 5 is 12. 14.5, 17. And another 5 is going to be 22. And this is 7 and this is 3. So this is going to be 4. 4 plus 22, 26. And then 29. Right? So it's basically some geometry calculation. So 0, 3, 7, 7. The diverse span is 7. And 7 plus 5, 12. 12. And then we have 14.5 to draw this shear wall in the middle. So 14.5 and 17. then 22, plus 426, and then 26 plus 3, 29. All right, I can take these copy, like I can copy all these values. Control C. And then I put them here, Control V. But there is a little bit of a change here. Why? Okay, everything is good in Y direction. 0, 3, 7, 7 plus 5 is 12. This is 1 meter, 3, and then 1 meter. So after 12, I have 13. Then 13 plus 3 is 16. And another 1 meter is 17. And then 17 plus 5 meter span is 22. Then 26. And then 29. How? All right, I have 0, 3, 7. 7 plus 5 is 12. 12 plus 1, 13. With 3, that all the lenses of the wall are 3. So 3 plus 11, 14, 15, 20. Oh, sorry. 12, 13. 13 and 3 is 14. Oh, yeah. So, sorry. Yeah, this is 13 plus 3 is 16. 16 and 1, 14. Oh, 17. And then you have 5, 22, and then 26, and then 29. All right. So we have it here, 26, 29. And I'm gonna keep these -3 and 0. Okay. So let's see what is gonna change in the grids. I'm gonna have this XY, and I'm gonna go to level number 0, this one. So I prepare the grids to match the structured system. And all what I have to do, maybe I can draw the shear walls right now. And to draw the shear walls, as we agreed, I'm gonna make the 3D model right away. So I'm gonna draw a frame element. The name is none. And I have a shear wall here. And another one here. I'm drawing a dummy element that I can extrude and draw the shear walls. And I have a core in the middle. I draw all the shear walls. I mean, like the frame element that I'm gonna use to draw the shear walls. If you wanna make them, so you can select all of them, edit, extrude, line to area, and the area is wall 30 centimeter, -3, 1, delete the source object. And then, and then I'm gonna say, okay. All right. The next thing is the columns. So let's draw joints. If you want to draw joints, you can draw special joint like this one. And I have column here, here, here. Here's a shear wall. I have columns at the 4 corners and 2 columns at the edges in the middle. And I have columns distributed each 5 meter. Okay, so I believe I drawn all the locations of the column. So I have the columns here, 2, 2. All right, so if I want to select these joints and extrude them, if I select all these, it's gonna select the joints that I drawn and the joints which is in the conditions of the shear walls. So can you see when I select everything? select two joints here. However, there is no columns here. But why there is a joint here? Because you have an area section. So it will be better if I select them separately. Let's escape. And I select this. I select these columns. So just make sure that you are selecting the right joint that has column without selecting the shear walls. I think I selected every column. So the next step is edit, extrude, points to frames, and I'm gonna make all of them as a column C1 50/50. If there's different cross section, you will have to define the new cross section. Okay, so right now I have all the columns drawn, right? Okay. So the next step, I draw the columns, I draw the walls. I can't draw the beams. It's a very easy step right now. So I'm gonna make the beam not none. I'm gonna make it beam 25 by 7. By the way, you will find all the frame sections that you define in this list, either columns or beam. So I have C1 and I have beam. So I will select the beam and I have beam on the perimeter like this. And I have a beam here, coupling beam that couple these shear walls. And I'm gonna get done with this. All right, so I have the beam drawn. So what else is missing? Beams, columns, shear walls, slabs, right? So let's draw one slab. Like I'm gonna draw this rectangle area and let's keep the slab 22 centimeter. And I'm gonna draw one slab like this from the start point to the end point, something like this. All right, so right now the slab is a one area. If you run this right now, it only has 4 points. It's not gonna feel everything in the middle. So I'm gonna divide this slab with the grid system. Why the grid system? Because this is where the columns and the shear walls and everything at. So let's divide the slab at the grid system. So the first division that I'm gonna have, I'm gonna select this slab and I'm gonna edit area and I'm gonna divide this area. And I'm gonna select to divide this area with the intersection of visible straight grid lines. Okay, let's see what is gonna happen. I'm gonna say okay. So right now I made sure that every column and every shear wall and every beam has a joint and is connected to the slab system. So joint is gonna, if you run them all, it's gonna be good. Like everything, the columns and shear walls is feeling the slab. What the not good is the mesh size is not uniform and it's not small. So the accuracy will be very bad. So we need to do another division. So I'm gonna select all this area and divide them into smaller pieces. So I'm gonna select all the area. So you will tell me, okay, you selected everything in the floor system, the beams, the joints, the slabs, and you want to do one thing to the area, is that you want to divide the area. So by selecting everything, isn't gonna mess up with the beams? No, because you can select your entire structure, but you know that this area, like you are selecting like the slab system with a frame system, but when you do operation to the area, it doesn't impact the frame system. So what I'm gonna do, I'm gonna say edit. It will open many options for you. Do you wanna, because you selected points, frames, and shells. Do you wanna do edit to the points that you selected or the frames or the area? I'm gonna select the area. So the other selections, it doesn't matter. So I'm gonna select the area and I'm gonna do another division to the area. So the next division that I'm gonna do to this area, I'm gonna divide the area into object that has maximum size. So I'm gonna tell SAP2000, I need you to divide these areas with a maximum size is 0.5 by 0.5. So they can be 0.4 by 0.4 or 0.3 by 0.3, but not bigger than 0.5 by 0.5. All right, so I'm gonna switch to divide area and I'm gonna make this 0.5 by 0.5 and I'm gonna say okay. So right now they are smaller pieces, okay? All right. So one thing. All right, so I did something that I wish I couldn't do, that I deleted the frame element that I used to draw this walls. Why? Because right now I wanted to divide these walls with the shell element. So I need to select the joint that's above the shear wall. I can't see where are the joints here. I know, yeah, there's a shear wall here, but where should I stop? So when I select that, will be like misleading. But if I have the frame element that I use to draw the shear wall, I will be able to see it and then select the joints around it. But right now I don't have it. So this is one mistake that I have done. Same thing here. I have a core here, like a core in this location. And this core, I need to remove the slab at the core because the core system is a shaft, like it doesn't have any area section. So I need to remove the area, but I can't see anything here. So let's see how we can do it. Maybe what I'm gonna do, I'm gonna make the area not in the view like this. And I know, let's zoom in, that the shear wall here. So I selected the joints and I know that the shear wall here and another one here. So I made the area, oh, okay, yeah, that's right. I made the area not in the view and just like showing the joints. Okay, so, yep, I selected all the shear walls on the boundary. Let me zoom in on the core to select the joints here. Okay, this shear wall, we can also select it. So I selected the joints that I'm gonna cut with the shear wall. So I selected the joint. The next selection is gonna be selecting the shear wall. Select, properties, area section, and select a wall 30 centimeter. So right now I selected the walls and I selected the joints that I need to cut the wall with. So next step is to go edit area, divide area, and I'm gonna say divide the area with the selected points. And I will say okay. So right now, if I give a deep look here, you'll find out that it's divided, right? So next step is I select the wall one more time. And I go to wall 30 centimeter. And I'm gonna make another division in the other direction so that I can make the aspect ratios 1. And I'm gonna divide it into 6 pieces. And I'll say okay. All right, so right now the wall is done. The next step is that I want to, let me restore the full view here. I want to delete the slab in the middle, like in this area. Okay, so let's select this and let's just show the slab. Sorry. Restore the full view and let's make the slab in the view. Apply. Okay, so right now I have where are the nodes at the end of this slab. So right now I can know which slab that I need to remove. So I'm gonna select all these meshes and delete them. Okay, so right now I deleted the slabs. So let's go to restore full view. So right now there is no slab at the shaft location. Where's the elevator at? Let me make a full view here. And full view here. Okay, you guys tell me what is missing. What else before I run the model? First is what? Yeah, so I'm gonna make fixed supports here, assign, joint, restrain. Let's assume raft foundation. If it's isolated footing, we usually make it hinge. If it's raft foundation or pile caps, we make it fixation. So let's make fixation here. Okay, so I made it fixed. The next thing is that I don't have any loads. Why? Because I removed the slab from previous example and I put the slab. So the only loads that we have is only the on weight of the structure. So let's put a live load in this structure. So I'm gonna select all the area here and I'm gonna assign area load and uniform. And I'm gonna put uniform live load on this equal to 150 kilogram, which is 0.15 ton per meter square. And I'm gonna say, okay, so I put live load. Right now, my model is done. And if you want to run it, all right. So this is the bending moment. If you want to see the bending moment diagram, how it looks like, you can actually take a section cut here. And you see how's the bending moment look like on this slab. And this is the deformed shape. If you want to see the deformed shape, display, show deformed shape. Okay. Something like this. And same thing, if you want to convert this into 3D, so you need to unlock your model or file, save as the model, and then you will say it's slab 4, for example, 3D. So once you save as the model, it's gonna unlock, and you can restart working on it, and you can change the view to set 3D view in XZ, and you select the entire structure without supports, including the shear walls, beams, columns, slabs, and then you go to edit, replicate, and make it 9 stories, 3, then you'll hit OK. So right now you will have a 3D structure. So this structure is ready for seismic and wind loads. We only do 3D models for seismic and wind loads. We do 2D models if we want to do gravity load analysis. Gravity means live load, dead load, roof live load, snow load. But you need a 3D model if you want to do a lateral force, because the columns and the shear walls is the one that we take. Since we have lots of details in this model, it takes a little bit, maybe a 1 minute or 2 minutes until it replicates. Also, running the model will take also much more time, maybe 5 minutes to run. Okay, yeah. So that's everything for now. I uploaded the SAP homework for you guys. Did you guys see it? Uploaded yesterday. You guys have until Monday, not Monday, the one after. So you have like 10 days to do it. Has some examples to practice. But if you watch these videos and you do these practice, I believe you will be able to do the homework. See you guys next time.